This is area lecture number 3, and this should take you through the weekend. And for this particular lecture, I'm going to be referring to some free response problems. You should probably go ahead and download these or print these out. Remember, they're on your class page. I'm looking at the area problem from 2002, Form B. I'm looking at the area problem for 2012 and 13 and 14. So again, I'm almost guaranteed that you're going to see one of these coming up this year. They have them for every year. And so certainly 2002B, we'll look at that one. That was 10 years ago, 15 years ago. But then we'll look at the more recent problems and sort of see how they differ a bit. Okay, so I've got a document here. This shows the region from 2002B. Oops, lost my region, 2002B. Notice that it consists of a line. The line is y is equal to 4 minus 2x. That's right here, 4 minus 2x. And some sort of strange rational function, which is x cubed divided by 1 plus x squared. So our task is to find the area of that region. So 2002B, again, y is 4 minus 2x, and y is equal to x cubed, 1 plus x squared. They don't give us any scale on the axis, but they do give us a picture. And so the first thing you should do is to try to duplicate this picture on your calculator. This was the line on top, and this is the rational function on the bottom, the x cubed over 1 minus x squared. Now, just knowing a little bit about lines, it's pretty easy to figure out this has got to be 4, right? So if x is 0, y is 4, and if y is 0, x is 2. So we could probably set up our window using those. Let's clear off this. We'll dump the line in on top, 4 minus 2x, and then the rational function, making sure we use parentheses for that bottom bit, x cubed divided by parentheses 1 plus x squared, and then set up the window. Let's go from -1 out to 3 by 1s, and then on the y's we'll go -1 to 5, and just take a look. See, again, we can go by 1s there. Okay, so there's our graph. That sort of mimics what we have. And our task is to find the area of the region, the area of this region. It's vertically simple. We're going to run vertical bars here, but we do need to know this point of intersection. They didn't give that to us. We find it very quickly on our calculator. Second calc, trace, intersect, bang, bang, bang. The intersection is this number 1.48. So 1.48766644. I'm going to say let A equal that. So then we go to our calculator. We'll just hit X. There it is. Store it as alpha A, enter. Okay, so now on my calculator, I know that's A. And lastly, the area is equal to the integral from 0 to A of this top one, which we called y1, minus the bottom one, which we called y2. y1 minus y2. And so on our paper, we should probably say, let y1 equal the top, and let y2 equal the bottom. So if we do that, then we can go straight to our calculator. Math 9, we're integrating. The top one is y1, vars, y vars, function y1. Take away the bottom one, vars, y vars, function y2, comma x, comma 0, comma alpha a, and that will give us our area. Okay, write that to the nearest thousandth. So the area equals, we've done this, and then you can simply say equals 3.215 rounding. Okay, so you can look at the solution and see whether that's good for there. Okay. Notice, by the way, that when we when we actually look at the problem, part B was a volume problem, part C was a volume problem. We'll do volumes on Monday and Tuesday and Wednesday of next week. Okay, the next one I want to look at is 2012, and the sketch looks something like this. This is the number 1. There's a line coming over here, 2, 3, 4. This is at 5, and we don't know where this is up here, although it appears to be slightly higher than 1. Okay, and our task is to find the area of this. Here's the picture the way it was presented. So area in the first quadrant bounded by the x-axis, the natural log graph, which is obviously this one. Y is the natural log of x, and the line y is equal to 5 minus x over here. Y is equal to 5 minus x. Now, there's more than one way of doing this. Because this is not vertically simple, I'm going to do this with horizontal rectangles. So I'm going to picture a horizontal rectangle running like this, and then stack them up from the bottom up to the top. I'm going to have to figure out how high this guy is. So let's go to the calculator first. We'll clear away these. Let's see, we've got y is equal to 5 minus x, 5 minus x, that's that line, and then the natural log of x. Okay, and for a window, let's say just on the other side, -1 again out to 6. And then for the y's, I do like to go a little bit below the axis. So I don't know, -0.2 might be enough. And then how high? It looks like it's more than 1. We'll go to 2. So here's our sketch. A little distorted, but that is the region that we're trying to find. Okay, we do need this point of intersection. So let me go ahead and find that. The point of intersection, bang, bang, bang. And notice that we know x is equal to, so this x coordinate right here, x is equal to 3.6934 and some change. And the y coordinate over here, y is going to be equal to 1.306558 and some change. Even though we're rounding answers to the nearest thousandth, for these preliminary calculations, it's always wise to put down more than the thousandth. So that's why I'm putting all these decimals down here. Okay, and let me go ahead and store these. The x coordinate I'll store as a, so sort of like before, you just hit x and you can store that as alpha a. I don't think there's any good way of storing the y coordinate. I think if you hit alpha y, I don't know that would come up. Hey, it does. That is the y coordinate. So let's store that as alpha b. Interesting. Didn't think that would work, but it does. Okay, so now I know my calculator knows that this is called a, and this number is called b, if I need those. Okay, let me go back to my page here. If I want to run horizontal rectangles here, I need to know the x-coordinate here, what is x equal to, and I need to know the x-coordinate here, what is x equal to, and then we can integrate by stacking these rectangles up. Okay, so the line's not too bad. We were told for the line this was y is equal to 5 minus x, so solving for x is 5 minus y. That's what this is. 5 minus y, 5 minus y. Now, for the log graph, we were told that y is the log of x, and so we know x is equal to e to the y, right? Just translating that from log form to exponential form. And so that's the x coordinate over here, e to the y, And now to find the length of this, we take the x coordinate on the right, which is 5 minus x, and subtract the x coordinate on the left, which is e to the y. Okay, so here's our area. Area is going to be an integral y running from 0 all the way up to that b number, right? We found this, we call that B. And we've got the right side is 5 minus y, and we're subtracting off the left side, which is e to the y, and that's how long that is, and then the thickness is a little piece of dy. So there we go. Okay, now unfortunately I entered neither of those two functions into my calculator. So for calculator purposes, I'm going to have to do math 9, and then I'm going to type in 5 minus y, and then I'm going to subtract off e to the y, right? E to the, and I'm just using alpha y here. So that's my integrand, comma, alpha y is my variable, right? Comma, 0, comma, and the top one we call b. Okay, so there's the area. And so you could do that equals 2.986 if I round that off, right, to the nearest thousandth. That's the area. That would work fine. Now, some of you may say, well, do you have to do it that way? And my answer is no, you really don't. You could do this with vertical bars, except it requires two pieces of work. So if we're thinking now we're going to find this area with vertical bars, we need to come straight down. We need to find the area of that, which is just a triangle. We could actually use geometry for that. And then the area of this, and add those two areas together. Okay, so if we wanted to get this problem done using area method 1 with vertical bars, we could do that. So let's see, now the area would be an integral from 0 to, we called this a, remember down here, 0 to a, and the top is the natural log of x, and the bottom is just 0, right? There's the log curve. This is y is equal to 0, so that will give us all of these guys, okay, dx. And then plus we would have to add the area of that triangle. And I suppose we could actually figure out the area of the triangle without too much grief, just using some basic geometry. This is 5, this is a, so the length of that, let's see, 1/2, the base is 5 minus a times the height. So you have to figure out how high this is. Let's see, we knew that y was 5 minus x, so the height is going to be 5 minus a, right? So that would be the area. And let me go ahead and dump that in on the calculator just to see that we get the same thing. So math 9, the natural log of x, that's a nice simple integral, minus 0, don't have to write that. X is the variable, x running from 0 to alpha a. Okay, so that's that guy. And then we also have to add this 0.5 times 5 minus alpha a. And I'm just going to square that because it does say 5 minus alpha times 5 minus alpha. So that should give us the same answer. And somehow we don't get the same answer. So where did we go wrong? Oh, isn't this fun? Next to A, I don't see where I'm going wrong. Y is the natural log of x. We got that. Okay, well, this is what happens when you record a lecture and you don't do things right. I'm going to have to come back and play with this one later. I don't want to spend any more time on it. Let's do this. Let's look and see what the answer is supposed to be. So I have all these on file. You have them as a download. I actually have them in a folder in my personal space here. So let's see, all the released questions. This was 2012, I believe. So 2012 solutions. Come on, baby. Scoring guidelines. Why is this not open? Okay. Feel free free to fast forward until I get this thing sorted out. Okay, I'll tell you what. I am going to, there we are, scoring guidelines. The answer was 2.986. 2.986. And note that there are two ways of doing it. This is the way we did it, and we got the right answer, 2.986 or 5. There's another way of doing it down here, and we should get the same answer. Now, they actually did it with an integral. I think you can do this with a triangle. We did say this was A. We know this is 5. So the base of the triangle is 5 minus A. And it is a right triangle, so we just need to go up. How tall is that? So we just needed to know, let's see, y is 5 minus x. If x is A, then that should be 5 minus A. You know, this is a 45, 45, 90 triangle. This is a slope of -1. So 5 minus A squared times 1/2. We add that to the area over here. We should be okay. So we did do this. I know I typed that one in right. And I thought I typed it in. So let me see. Let me grab my calculator again and see what I actually did. I did integrate the natural log of x from, there's my problem. Look at the lower limit. The lower limit was 1, not 0. So let's change that back to 1. Then we should be okay. Yeah, sure enough. Okay, so sorry about the misread there. When we're stacking the rectangles vertically, we are going from 0 all the way up to this point, whatever that number was. That was B. When we're going vertically, though, we're not starting from 0. We're starting from 1 up to A, and then the area of the triangle. Okay. So, yeah, a little bit of goof up there. That was 2012. Notice, by the way, that part B of this problem is a volume problem. Part C is, in fact, an area problem. So maybe we can do part C as well. Let me pull up my class page. Part C says the horizontal line divides the region into 2 regions of equal area. So quick sketch again. Here's your log curve. Here's the line. And now you have to envision a horizontal line dividing this into two regions of equal area. So we've sort of seen one like this before, and the task is find the value k. Where is this k number that will divide this into 2 regions of equal area? Notice it says you don't even have to find k, you just have to write an equation involving one or more integrals that will give you the solution. Okay, so I'm going to go to my horizontal rectangle again. We had done this previously. Go back here. Remember when we integrated this, we did it this way. That gives us the entire area. So what we want to do now is we want to go not from 0 to B, but 0 to K. Let's put a K there. So we're not going up to B, we're going up 0 to K. And so we're just getting this much. And we don't want it to be 2.986, but rather half of that. So times 1/2. And that would be sufficient. Okay, so if you did this, that would give you full credit for part C. That was actually an easy problem once you had muddled through part A. Okay, 2013. We'll try to do this one a little bit more cleanly. Okay, now, big problem with 2013, no calculator. The way the test is structured, calculators are permitted for free response problems 1 and 2, but no calculator on free response problems 3, 4, 5, and 6. Okay, so, and that was a fairly recent change. I think 2011 or 12 they made that change. 2013, problem number 5, no calculator. And here's the document that I've got. 2013. We have this region. They do tell us that this point up here is 4, and this point is 2, so those numbers are given. And then they have f described as a parabola, 2x squared minus 6x plus 4. You have to know some basic ideas on algebra. This is a parabola, and it's opening up, right, because the x squared is positive, which means the parabola has to be this bottom curve down here. And g of x is given as 4 times the cosine of 1/4 pi x. And we have no calculator, and yet we're supposed to find the area of this region. Okay, so because there's no calculator, my guess is that the integration is going to be pretty easy to do. We've got our parabola going like that, and this is 2, and this is 4. Okay, and we have our curve, our cosine curve, going like that. This is given as the cosine, right? Well, actually, it's not given as the cosine. You had to know that the cosine is on top for cosine of 1/4 pi x, and the parabola is on the bottom, which is f. And again, 2x squares minus 6x plus 4. And the task is find the area. Okay, vertically simple. We're going to run our bars like this. So the setup is actually pretty easy to do. It looks like the integration may be the hard bit. So the area is going to be an integral from 0 to 2, right? 0 here, going all the way over to 2. So we're running these vertical bars. Whoops, don't want to go there. Vertical bars starting here, right? And the top is going to be 4 cosine of 1/4 pi x, and the bottom now is going to be this parabola, 2x squares minus 6x plus 4. Okay, so that's going to give us the length of the bars and dx. Okay, so there's the setup. I think if you actually wrote that, you probably got a point or maybe even 2. Would have to look at the rubrics and see how they graded this thing. But let's go ahead and do the integration. Okay, so I'll go ahead and distribute the minus sign so I don't lose that. We're integrating from 0 to 2. 4 cosine of 1/4 pi x minus 2x squared plus 6x minus 4 dx. And obviously the antiderivative is down here easy. This is minus 4x, this is plus 6x squared over 2, and this is minus 2x cubed over 3. So those antiderivatives are a piece of cake. The first one gets a little bit more intriguing. You know, how would you integrate this? Well, the 4 stays there. So I'm sort of scratch work off to the side. What is the antiderivative of 4 cosine of 1/4 pi x? And you might want to think it's a trig one. You know, the integral of cosine of u du is sine of u. Okay, so the 4, you can just get that out of there. Don't need that. And then the u is pi over 4x. So the du is going to be pi over 4 dx. We don't have pi over 4 dx. All we have is 1 dx. So you put in a pi over 4 and balance it with a 4 over pi, right? So now we have 16 over pi out front. And then we should be okay. So the answer, the antiderivative, if you will, is going to be 16 over pi. The integral of cosine is sine, and the angle stays the same, 1/4 pi x. Never change the angle when you're integrating. Okay, so there's our antiderivative. I guess 16 over 4 is just, 16 over pi, sorry, 16 over pi. Okay, now let's stick in the numbers, 0 and 2. The 0 sort of makes me smile, because typically when you put 0 in, things are going to be nice, but we do have to put the 2 in. So let's see if we can do that. We do have to find the area. So the area is equal to parentheses minus parentheses. And again, just checking, when you put the 0 in, let's see, the sign of 0 is 0, that's 0, that's 0. So this whole thing is just 0. But let's put the 2 in and see what we get. No calculator. So we have 16 over pi. We have the sign. Now we're putting 2 in for x. So that gives us 2 pi over 4 or pi over 2. Okay, we're putting 2 in for x here. So that's 2 times 8 over 3 plus 6 times 4 over 2 minus 4 times 2. Are we supposed to know what the sign of pi over 2 is? Yes, we are. Basic unit circle question. Pi over 2 is the top of the circle. Right? Pi over 2 is up here. 0, 1. The sign is equal to 1. Okay, so answer, we have 16 over pi times 1 minus 16 over 3 plus 12 minus 8. And there you go. You could leave it there. I suppose you could even leave it like this, but you do have to know the sign of pi over 2 is 1. They're not going to let you get away with that. Okay, so there's our answer. That was an area problem with no calculator. Okay, the last one I want to do in this third lecture is the one from last year. Last year, students were given this problem. This is 2014. Here's my scanned page, 2014. It just says, find the area of region R. It says that the line is y is equal to 4. Y is equal to 4. And the curve is a crazy y is equal to x to the 4th quartic minus 2.3, ugly decimal there, 2.3 x cubed plus 4. Notice this is problem number 2, which says, we can use a calculator. So the first thing I'm going to do if I were presented with this is go to my calculator and dump these guys in here so I can actually get a picture. Y is equal to 4, I know what that looks like. And y is equal to x to the 4th minus 2.3 x cubed, and then plus 4. Okay, I should probably, look at it in the standard window, zoom 6, and then realize I just need this little portion over here. Let me put a box around it. That's always a fun thing to do. Zoom box. Go up and find a corner of the box. Let me go over to the left just a bit. So there's one corner. And then let me find the diagonal. Whoops, where to go? Find the diagonal corner. I guess I lost my first corner. This emulator is not user-friendly. Zoom box. Okay, so there's one of them. Then I'll arrow over. I thought I could hold this down, but I guess I can't. Come on, baby. Coming up. Class is almost over. Okay, so there's my graph. I am going to need this point of intersection, so let's go ahead and find that guy. Point of intersection over here. I have to get close to the point of intersection, and then I can go enter, enter, enter. And I need the x coordinate, which is 2.3. Okay, so that makes things particularly nice. X is 2.3 right there, 2.3. And I'm just thinking I'm finding boxes. This is vertically simple. The top is always the line, and the bottom is always the quartic. So my area is going to be an integral from 0 to 2.3, 4 minus. Now again, I think it's important to have these parentheses here. It's x to the 4th minus 2.3x cubed plus 4. That's the length of my bars, dx. I don't need the antiderivative here, right? I have my calculator, so I can do that on the calculator. Second quit, and Math 9. The top is 4, and the bottom we called Y2, right? Comma X, comma 0, comma 2.3. 2.3. Okay, something's not right. 0 to 22.3. Let's try that again. Garbage in, garbage out. Let me take away there, 2.3. Okay, that makes sense. The area is 3.218. So equals 3.218. Done. Again, look at part B. It's a volume problem. Part C is an area problem. So we're going to do part C again. Here's the sketch. There's our line. Y is equal to 4. We have this quartic that's looking like that. This is down here at 2.3. And if you read part C, it says the vertical line, x equals k. So again, here's my vertical line, x is equal to k. But as you move it around, it divides it into two parts that have the same area. So I don't know, maybe somewhere right around there. Okay, so we want it, wherever we put it, we want it so that the area, come on baby, there we are. The area to the left of this is supposed to be the same as the area to the right of this. And the task says, write but do not solve an equation involving integral expressions whose solution gives the value of k. Okay, so this gives us our, well, let's see, we've already got this here. And we know, let me write this number down. This is 3.218. And actually it was a 3.21817, right? So I'll sort of keep that extra digit there. That's the whole area. I want half of that. So let's see, divided by 2. So that gives us 1.609. Divided by 2 is 1.609. And then what we want to do is we want to integrate from 0 to k, right, is equal to this. That should be it. Okay, and we don't have to find k. So, and then we take away the area here. Okay, so integrate from 0 to k. Here's the k value. And that's it. Feel free to look at the rubrics. We'll do the volume parts Monday, Tuesday, Wednesday. Now, what should you be doing on your own? You should go into those free response questions, find some area problems, start to work them. Our test on Friday will be basically three problems that deal with area and volume. So you're going to have to do some areas, you have to do some volumes. And if you just practice the area stuff now, I'll just pick one of the ones that have been released. Basically, all those there are valid test questions. So you start doing them all if you want. The answers are there as well. And then that will be our test on Friday. Okay, volumes on Monday and Tuesday. Have fun in the snow. Let me go ahead and stop this guy. We're 33 minutes in now. Bye-bye.